Hello everyone, this lecture video is all about accuracy and precision. Let us first define this one. This topic is under measurements. First, we have here accuracy. It refers to how close the measured value is to a standard value. For precision, this refers to how close to one another the measured values in a series are. To understand this better, I have here some diagrams. And let us analyze this one. So assume that you are playing darts and the goal is to hit the center, this one. This is the center and this is the standard value or the standard point. So here in figure A, the dots of the darts, this one, the circles here, hit the center, which means that it is accurate because of the closeness of the dots to the target, because this is your target, this is the standard target. So this is therefore accurate. And then you can also notice that the dots here are very close to one another. They are very close to one another, therefore they are precise. Because if you will look back the definition of precise, they must be close to one another. Okay. And then, therefore, the figure A is about accurate and precise. Next, I have here the second figure, letter B. For letter B, the dots here are close to the standard value. Okay, they are close within the target circles. And then, but the dots here are not close to one another. So since the dots here are close to the standard value, meaning to say it shows an accuracy. But since the dots are not close to one another, they are not precise. So the values measured here in the figure B are accurate but not precise. So next we have here figure C. The dots are very far from the standard value. This is your standard value, the standard target. Since they are far from that, therefore this is not accurate. But then if you will notice, the dots are close to one another. So the dots are precise. So we can say that the values here in the figure C are precise but not accurate. Next, I have here the figure D. The dots are far from the standard value, as you can see. It's far from here. And then they are also far from one another. So the values here in figure D are neither accurate nor precise. Not accurate and not precise. Now let us proceed on the integration of figures in accuracy and precision. So let us say in terms of numbers. I have here figures. The problem here, the standard measure of, let's say, a coffee table, the length of a coffee table is 16 centimeter. Okay, that is the standard value. Let me write that, 16 centimeter. Okay, standard value is 16 centimeter. And then, let us determine whether the student's measurements are accurate, precise, or both based on this table. I have here this table. Okay, so the first measurement, it is close to 16. So this is accurate. Second measurement, it is close as well. Third measurement as well. So therefore, this is accurate. The data of the student are accurate. And since they are close to one another, they are also precise. So to determine the accuracy of the given measurement, we will get first the average of the measured values. So to get the average, you just have to add all of these, adding that up and then divide it into 3 since you have 3 measurements. And then you have here 15.87 centimeters. So from this one, this is the measured value, the 15.87. And then the standard value, as I have mentioned earlier, is 16. So the average value that is equal to 15.87 centimeters is close to 16 centimeters, is the standard value. Therefore, we can conclude that the measurements are accurate. And since they are close to one another, the data here, if you will round that off, so that is 16, the values are also precise. So the data here are both accurate and precise. Next, I have here another data. So we have here, as you can see, 4 students need to measure how much of an unknown substance should be put in their experiment. So let's say this is a sodium chloride or a table salt. So they perform 3 measurements, trials, let's say first measurement, second measurement, and third measurement. And then we have to determine whether their measurements are precise, accurate, or not, given that the standard measurement of the unknown substance is 80.6 grams. Okay, so I'll write that up. We have here the standard measurement is 80.06 grams. Let us analyze the measurement of student A. This one. This is his work or her work. So the student A obtained measurement values that are far from one another. They are far from one another. We have here 48.70, 55.50, and 70.03. So therefore, this is not precise because they are not close to one another. And then, if this is the standard value, the average or the measured value is 58.08. If you will divide and add these values here, this is also not accurate. So student A, the measurements of student A is neither accurate nor precise, not accurate and not precise. I have here next, let us analyze the work of student B. For student B, we have here the measurements are also far from one another. We have here 78.53, 54.98, 109.00 grams. Since the values are far from one another, therefore the measurements conducted by student B is not precise. And then, if you will look here for the average, 79.94, if you will round that up, that is 80, so that is near to the standard value. This is the measured value here. So it is near to the standard value, therefore this is accurate. So therefore, the measurements of student B is accurate, but not precise. Now let us proceed on student C, this one. So for student C, we have here the values of 79.05, 80.15, and 81.00 grams. And then the average is 80.60 grams. Now let us analyze. The measurements obtained from the three measurements are close to one another. We have here 79, 80, and then 81. And then the average is exactly the same. The measurement is exactly the same as the standard measurement here. So this is both precise and accurate for student C. Now let us proceed on student B. For student B, let us have here this one. The first measurement, 60.25, 58.08, and then 59.11. The data here they are close to one another. We have here 58.08 and 59.11, and then the average is 59.15. So we can say that for letter D, this is precise because we have here the two that is close with one another, as well as 60.25. So this is precise, but the average measurement is far from the standard measurement here, the target measurement, so this is not accurate. The measurement of student B is precise, but not accurate.